Good evening, mathematicians. Tonight we're going to look at two different word problems and think how the wording in the problem can help us to solve them, both with an algorithm and with a model. So let's look at the one inside the orange box. Ariel has 2 1/3 pounds of blueberries. I'm going to underline that. It seems like it's important information. She uses 3/4 of them. So I'm going to underline that. 3/4 of them. So it's 3/4. I'm going to write this down. This is information I can use. It's 3/4 of the 2 1/3 pounds to make a pie. How many blueberries did she use? Okay. So we know that if it's 3/4 of the original problem, this of is really telling us that it's multiplication. So it's 3/4 of 2 1/3 is 3/4 times 2 1/3. We know that we need to change this mixed number into an improper fraction in order to solve this equation. So we'll do 3/4 times 7/3 because we need to multiply 2 times 3, add 1, that's 7, the denominator stays the same. Great news, we can simplify before we reduce. 3 and 3, if we divide them both by 3, we get 1, and now when we solve it, it'll be super easy. 1 times 7 is 7, 4 times 1 is 1, and it looks like she uses 1 3/4 pounds of blueberries. If I wanted to represent this with a bar model, I'll just shrink. Oops, can't shrink that. What I would do is draw 2 1/3. So the way I would do that is I would draw thirds, I would draw thirds, and I would draw one more because when I shade it in, 1, 2, 3, that's one hole, 2, 3, 4, 5, 6. That's a second hole, and it's 2 1/3. So I only have one more box here. If I'm going to use 3/4 of them, I would divide each one into 4 pieces. And then to show that I want 3/4, I would use the top 3 lines, and that would be equal to, if I hadn't reduced, that would have been equal to 3/4, 7/3. It would have been 21/12, because remember, it's how many boxes are there in one box. How many did we divide one box into? And so 21/12 would have been equal to 1 and 9/12, which is equal to 1 3/4 pounds. Great. Well, let's see how this other one compares, this other problem. Ariel picks some blueberries, so we still have some blueberries. She uses 5/9 to make jam. Well, let's start showing this right off the bat. I'm going to divide my bar into ninths. 1, 2, 3, 4, 5, 6, 7, 8, more or less equal. And she uses 5/9 to make jam. So here we have 1, 2, 3, 4, 5. So remember, we need numbers and words. So 5/9 is for the jam. Then it says, and I'll underline that, that was 5/9 for jam. She uses half of the remaining. Because it says remaining, we care about this part, the part we haven't touched yet. It's not half of the 5/9, then we would be multiplying. It's half of the remaining. Half of the remaining, well, I have 1, 2, 3, 4 boxes left. Half is just these two. So half of the remaining is right here, and that's to make pie. So I'm going to write pie. The question says, what fraction of the blueberries did she use to make pie? Well, I had 2 boxes, so the fraction is 2, and a lot of you might put 4, but guess what? That's not how many boxes there are in the whole bar. How many boxes were there? 1, 2, 3, 4, 5, 6, 7, 8, 9. She used 2/9 of the blueberries to make pie. So friends, when you're looking at word problems, really take time to annotate and understand, what is this problem asking me? How can I represent it with an algorithm and with a bar model to help me solve it? Great, good luck.